Space is a vast and mysterious place. It's full of wonder. Planets and moons move with clockwork precision. Sometimes these celestial objects align perfectly. They create stunning visual displays. We call these events transits and eclipses. They are celestial shadow plays. They offer a glimpse into the intricate workings of our universe. These events are not mere cosmic curiosities. They are valuable opportunities for scientific observation. By studying how light interacts with these objects, we can learn a great deal. We can determine the size and composition of planets and moons. We can even detect the presence of atmospheres. Join us on a journey through the solar system. We'll explore the bizarre shapes that block the sun. From the familiar eclipses on Earth to the rare transits of distant worlds, we'll unravel the secrets these events hold. Get ready to be amazed. The universe is full of surprises. Let's go! Earth has a front row seat to some spectacular shadow play. This cosmic ballet is a mesmerizing display of celestial mechanics where the Earth and Moon engage in a delicate dance orchestrated by gravity. Our faithful companion, the Moon, is the perfect size and distance to create total solar eclipses. These events are rare and awe-inspiring, capturing the imagination of people across the globe. During these events, the Moon passes directly between the Sun and Earth, aligning perfectly to cast its shadow. It casts its shadow upon our planet, creating a path of darkness that sweeps across the Earth's surface. For a brief time, the Sun's brilliant disk is completely obscured, plunging the day into an eerie twilight. Only the faint, ethereal corona is visible, a halo of light that hints at the Sun's hidden power. This is a truly awe-inspiring sight, one that leaves onlookers with a sense of wonder and amazement. It's no wonder that eclipses have fascinated humanity for centuries, inspiring myths, legends, and scientific inquiry. But the Moon isn't just a passive player in this cosmic dance. It has its own story to tell, one that is equally captivating. It also experiences eclipses of its own, where the roles are reversed, and the Earth takes center stage. From Earth, we call these lunar eclipses. They occur when the Earth passes between the Sun and the Moon. During a lunar eclipse, the Earth's shadow falls upon the lunar surface, creating a dramatic and beautiful spectacle. The Earth's shadow falls upon the lunar surface, but the Moon doesn't completely vanish. Instead, it takes on a reddish hue, a phenomenon that has captivated skywatchers for millennia. This reddish color, often referred to as a blood moon, is due to the scattering of sunlight through Earth's atmosphere. This is because some sunlight is refracted through Earth's atmosphere, bending around the planet and illuminating the Moon. It's like watching a sunset reflected on the lunar surface. Stunning! This interplay of light and shadow is a reminder of the intricate and beautiful dance between Earth and its Moon. As we venture further into the solar system, we encounter the inner planets, Mercury and Venus. These rocky worlds also put on a show for us, albeit on a smaller scale. Mercury, the smallest planet in our solar system, occasionally transits the Sun. During a transit, Mercury appears as a tiny black dot moving slowly across the Sun's disk. These events are relatively rare, occurring only about 13 times per century. Venus, our planetary neighbor, also makes transits. These are even more infrequent. Venus transits occur in pairs, separated by over a century. The last transit of Venus took place in 2012. The next one won't happen until 2117. Though these transits may seem insignificant because of their size, they offer valuable insights to astronomers. They allow us to refine our measurements of planetary orbits and study the thin atmospheres of these worlds. Mars, the red planet, boasts two small moons, Phobos and Deimos. These moons, named after the Greek gods of fear and terror, are fascinating celestial bodies that have intrigued scientists and astronomers for decades. These moons are irregularly shaped, resembling asteroids more than the spherical moons we are familiar with. Their surfaces are covered in craters, evidence of countless collisions over millions of years. They're much smaller than our own moon, with Phobos being about 22 kilometers in diameter, and Deimos even smaller at around 12 kilometers. In comparison, Earth's moon is a giant, with a diameter of 3,474 kilometers. While they don't completely block the sun, they create partial solar eclipses. These events are quite different from the total solar eclipses we experience on Earth, but they are no less spectacular. Imagine standing on the surface of Mars. The sky above you is a dusty pink, and the landscape stretches out in a vast rocky expanse. You look up and see the familiar disk of the sun, though it appears smaller and dimmer than it does from Earth. Suddenly, a small, dark shape begins to move across its surface. This is Phobos, making its rapid transit across the Sun. It's Phobos, the larger of Mars' two moons, casting its shadow upon the planet. This shadow moves quickly, a testament to Phobos' rapid orbit around Mars. These Martian eclipses are fleeting events lasting only a few moments. Phobos orbits Mars in just over 7 hours, so these eclipses occur frequently but are over in the blink of an eye. Phobos and Deimos are small, but their presence is a constant reminder of the dynamic nature of the Martian sky. They zip across the Martian sky relatively quickly, with Phobos rising and setting twice each Martian day. But thanks to robotic explorers like the Curiosity rover, we have been able to witness these events up close. These rovers have provided invaluable data and stunning visuals of these celestial phenomena. The images and videos captured by these missions provide a unique perspective on the dynamics of the Martian system. They allow us to experience these events as if we were standing on the surface of Mars ourselves. They remind us that even on a planet as seemingly desolate as Mars, there is still beauty and wonder to be found. The Martian moons, with their rapid orbits and dramatic eclipses, add to the allure of this mysterious world. Section 5. Jupiter, a celestial ballet of shadows. Jupiter, the king of the planets, reigns over a vast and dynamic system of moons. 4 of these moons, Io, Europa, Ganymede, and Callisto, are particularly large and active. They regularly transit the Sun from Jupiter's perspective. Imagine gazing up at the sky from Jupiter. The immense swirling clouds of the gas giant dominate your view. But then, a shadow begins to creep across the cloudscape. It's one of Jupiter's giant moons, casting its silhouette upon the planet below. These Jovian transits are not rare occurrences. They happen frequently. Sometimes multiple moon shadows can be seen simultaneously. It's a celestial ballet of shadows, a testament to the intricate dance of gravity and orbital mechanics. Section 6. Saturn, the ringed master of occultations. Saturn, the ring jewel of our solar system, is a master of celestial shadow play. Its iconic rings, composed of countless icy particles, create a stunning backdrop for a variety of occultation events. Imagine yourself aboard the Cassini spacecraft. You're orbiting Saturn. You're surrounded by the ethereal beauty of the rings. Suddenly you notice a change in the light. A moon is passing behind the rings, its silhouette momentarily interrupting the intricate patterns. Saturn's moons also play hide-and-seek with each other and with the rings. They create a constantly shifting tapestry of light and shadow. These events are not just visually stunning. They provide valuable data to scientists. They help us study the structure and composition of Saturn's rings. Section 7. Distant encounters, Neptune, Triton, and Pluto. As we venture to the outer reaches of our solar system, we encounter the ice giants, Neptune and Uranus. These two planets, often overlooked, are shrouded in mystery and intrigue. Their immense size and unique compositions make them fascinating subjects of study. These planets may be far away, but they still hold surprises. Neptune, with its deep blue hue, is known for its strong winds and dynamic weather patterns, including the fastest winds in the solar system. Voyager 2, during its epic journey through the solar system, captured images of Triton, Neptune's largest moon, transiting the Sun. Triton is unique because it orbits Neptune in the opposite direction of the planet's rotation, a phenomenon known as a retrograde orbit. These observations were a testament to the power of human ingenuity and the vastness of our solar system. The data collected by Voyager 2 has been invaluable in expanding our understanding of these distant worlds. They also provided valuable data about Triton's atmosphere and size. Triton's thin atmosphere is primarily composed of nitrogen, with traces of methane, making it a subject of great interest for scientists studying planetary atmospheres. Even Pluto, demoted to dwarf planet status, has a role to play in celestial shadow play. Despite its reclassification, Pluto remains a key object of study in understanding the outer regions of our solar system. The New Horizons mission, which gave us our first close-up look at Pluto, also captured images of Pluto eclipsing the Sun. This mission has provided unprecedented insights into Pluto's characteristics and its place in the solar system. These images reveal details about Pluto's thin atmosphere and surface features. The surface is marked by mountains, valleys, and plains, indicating a complex geological history. They highlighted the fact that even the most distant objects in our solar system can reveal their secrets through shadow play. The interplay of light and shadow helps scientists uncover the hidden details of these remote worlds, enriching our knowledge of the cosmos. Section 8. Exoplanet Detectives Transits Across the Cosmos. The quest to find planets beyond our solar system, known as exoplanets, has captivated astronomers for decades. One of the most successful methods for detecting these distant worlds is the transit method. This method relies on the same principle as the transits we observe in our own solar system. Imagine a distant star, light years away. As you observe this star, you notice that its light dims slightly at regular intervals. This dimming is caused by an exoplanet passing in front of the star, blocking a tiny fraction of its light. By carefully analyzing these dips in brightness, astronomers can determine the size, orbital period, and even some atmospheric properties of exoplanets. The transit method has revolutionized our understanding of planetary systems beyond our own. It has revealed a staggering diversity of worlds. Section 9. Conclusion. Unlocking the secrets of the universe. Celestial shadow plays, from the familiar eclipses on Earth to the transits of distant exoplanets, are more than just visually stunning events. They are windows into the intricate workings of the universe. By studying these events, we gain a deeper understanding of planetary systems, stellar evolution, and the fundamental laws of physics. As we continue to explore the cosmos, we can be sure that many more celestial shadow plays await our discovery. Each event will offer new insights, new wonders, and new reasons to marvel at the vastness and complexity of our universe. So keep looking up and never stop exploring.